Back in the 1950s, the Aral Sea was one of the largest freshwater lakes on the planet and supported an entire region across Central Asia. The Sir Darya and Amu Darya rivers constantly supplied it with water, creating a thriving fishing industry that fed and employed tens of thousands of people. But everything changed when the Soviet Union launched an ambitious plan to transform the dry lands of Central Asia into one of the biggest cotton-producing regions in the empire. To achieve that goal, massive irrigation systems were built across the desert. Tens of thousands of kilometers of canals, along with dozens of dams and reservoirs, redirected water away from the Aral Sea and toward cotton fields. The major problem was that most of these canals were simply dug into loose desert sand without proper concrete lining. Huge amounts of water leaked into the ground or evaporated before ever reaching the farms. Year after year, less and less water flowed into the Aral Sea until the supply nearly disappeared completely. Once evaporation became greater than the amount of incoming water, the entire ecosystem began collapsing. Water levels dropped so dramatically that by 1987, the Aral Sea officially split into two separate bodies of water. Vast sections of the exposed seabed turned into the toxic Aralsco desert, filled with salt, fertilizer residue, and dangerous chemicals left behind from decades of agriculture. Every year, powerful dust storms carried millions of tons of contaminated salt across the region, creating a growing health crisis for nearby communities. While most of the world had already given up on the Aral Sea, a small group of local engineers in Kazakhstan realized there might still be one final chance to save the northern part of it. They discovered that the North Aral Basin was deeper and still received water from the Sir Darya River. The problem was that nearly all of that precious water kept escaping through the Berg Strait into the southern basin, where it quickly evaporated across the dry desert floor. The North Aral was basically acting like a bathtub being filled with water, while the drain remained completely open. In 1992, local engineers and residents decided to attempt something many people considered impossible. Without a major budget or advanced technology, they used trucks loaded with sand, soil, and rocks to build a rough barrier across the strait and stop the water from flowing south. Surprisingly, the temporary structure actually worked. Water levels in the North Aral slowly began to rise, humidity improved, and fish started returning after years of disappearance. But nature was not easy to defeat. In 1999, a massive flood created enormous pressure against the weak earthen dam and destroyed it completely. 2 workers lost their lives, and all the water that had accumulated over several years rushed back into the South Aral and disappeared once again. Even though the project failed, it proved something extremely important. The idea itself was correct. The only thing missing was a strong enough dam capable of holding the water in place. After the collapse of the earthen barrier, Kazakhstan and the World Bank decided to launch a much larger project to save the North Aral Sea. In 2005, the Kokaral Dam was officially completed. Stretching about 13 kilometers long, the structure was built using millions of tons of compacted earth and reinforced concrete, strong enough to stop water from escaping into the southern basin. The operating principle behind the dam was actually very simple. When water is concentrated inside a deeper and narrower area, less surface is exposed to heat and wind, which greatly reduces evaporation. The Kokaral Dam transformed the North Aral from a wide, shallow basin into a deeper body of water capable of holding water far more efficiently. The project also included a modern spillway system designed to control flooding and flush excess salt out of the lake. At the same time, Kazakhstan upgraded large sections of the Sir Darya River channels to reduce water loss before it could reach the sea. Experts originally believed it would take several years before the North Aral showed any real signs of recovery. But something incredible happened. In only about 7 months, water levels began rising much faster than anyone had predicted. The transformation after the Kokaral Dam began operating went far beyond what scientists had expected. As salinity levels in the North Aral dropped dramatically, many freshwater fish species that had disappeared for decades started returning naturally, without any human restocking programs. Migratory birds also began appearing in growing numbers around the shoreline. Vegetation slowly recovered, and an ecosystem once considered completely dead started functioning again, little by little. Alongside nature, human life also began to recover. The fishing industry, which had fully collapsed years earlier, returned with thousands of tons of fish being harvested every year. New seafood processing plants were built along the coast, creating jobs for thousands of local residents. Villages that had once been abandoned slowly became populated again as families returned home. While the North Aral was gradually coming back to life, the South Aral continued drying out and turning into an enormous desert. Even though the Aral Sea will never return to the enormous size it once had, the recovery of the North Aral is still considered one of the most remarkable environmental comebacks in the modern world. The Kokaral Dam project proved that even an ecosystem that seemed completely dead could still be revived if humans intervene in the right way and work with the laws of nature instead of against them. What makes this story even more fascinating is that the solution did not rely on extremely advanced technology. By simply controlling water flow and reducing water loss, Kazakhstan managed to completely change the future of an entire region. It also serves as a warning for many lakes and ecosystems around the world that are slowly disappearing because of overexploitation and poor resource management.